every time Earth goes around the backside between the sun and Jupiter, Jupiter's going to tug on it a little bit.
NASA's final images of interstellar Comet 3 I/ATLAS have revealed something that's keeping astronomers awake at night. This cosmic traveler, which journeyed millions of light years to reach us, is now literally falling apart as we watch. Unlike any comet ever observed, it's made of exotic carbon dioxide instead of water, glows with alien chemistry that defies physics, and appears to be fragmenting in real time. We have just weeks left before it vanishes behind the sun forever, taking its otherworldly secrets with it. What scientists are discovering in these final moments is rewriting everything we thought we knew about the universe. The shocking revelation. NASA's latest revelations about 3 I/ATLAS have stunned the astronomical community and reshaped our understanding of interstellar objects. On the 7th of August, 2025, the agency released what many are calling the most important astronomical image of the decade, captured by the Hubble Space Telescope on the 21st of July. The breathtaking detail revealed clues about the true nature of this mysterious traveler, leaving scientists grappling with more questions than answers. The most shocking discovery lies in the size of 3 I/ATLAS's nucleus, which could be anywhere from a staggering 3.5 miles across to as little as 1,000 feet. That kind of uncertainty is highly unusual and suggests that the object might not fit neatly into the category of a comet at all. Adding to the puzzle, Hubble detected a dust plume and tail unlike anything ever observed. Instead of the orderly behavior typical of comets, this one appeared asymmetrical, chaotic, and influenced by forces beyond current scientific explanation. The timing makes the discovery even more dramatic. 3 I/ATLAS will only remain visible through September 2025, before its path takes it too close to the Sun for observation. That means every moment counts as scientists race to gather data before the cosmic visitor disappears from view. Each new image uncovers details that challenge established comet models, force us to reconsider what we thought we knew about interstellar bodies, and, by extension, planetary systems beyond our own. The Hubble breakthrough. The Hubble Space Telescope's latest images of interstellar Comet 3 I/ATLAS stunned astronomers by revealing a bizarre teardrop-shaped dust cocoon trailing its nucleus. Unlike the smooth, sun-driven arcs of typical comet tails, this one looked chaotic and organic, almost as though the comet was bleeding into space. Instead of shedding material in steady streams, 3 I/ATLAS ejects bursts of particles in uneven, unpredictable jets, creating a coma that is patchy and volatile. Even stranger, its nucleus is darker than charcoal, hinting at a composition completely alien to anything in our solar system. Adding to the mystery is the comet's extreme size-to-activity ratio. Though the nucleus is relatively small, no larger than 5.5 kilometers, it produces an enormous halo of dust and gas, far greater than astronomers would expect from such a tiny body. It's like a basketball generating a dust cloud the size of a stadium, suggesting the comet may be composed of hypervolatile materials unknown to science. This level of outgassing is so intense that it obscures the nucleus, making it unusually difficult to measure and fueling speculation about its true structure. Some researchers now suggest 3 I/ATLAS might not even be a solid object at all, but a fragile rubble pile of smaller pieces barely held together by gravity. If so, the sun's heat could be forcing it to fall apart before our eyes, offering a rare glimpse of an interstellar body in its death throes. Whether it's built of exotic chemistry, unstable ices, or an entirely new kind of cosmic structure, 3 I/ATLAS challenges everything astronomers thought they knew about comets and raises the unsettling possibility that the universe holds materials and processes we've never encountered before. The James Webb revelation. The James Webb Space Telescope's observations of 6th of August, 3I/ATLAS, have revealed chemical and physical behaviors that defy everything astronomers thought they knew about comets. Using infrared imaging at key wavelengths, Webb found the interstellar visitor to be nearly invisible in water vapor while blazing bright in carbon dioxide. This is highly unusual, since water is normally the dominant volatile in comets. Instead, 3I/ATLAS seems to be built of dry ice and other exotic compounds, its coma pulsing outward in waves of activity rather than releasing material in a steady flow. This bizarre chemical fingerprint is unlike anything found in the solar system, suggesting origins in a very different kind of planetary environment. Adding to the mystery, Webb's spectroscopic data detected complex organic molecules that normally require extreme conditions to form. Combined with the strange, chaotic dust tail seen by Hubble, 3I/ATLAS is behaving in ways that don't fit established comet physics. Rather than following smooth arcs shaped by solar wind, its tail is twisting into tangled, spaghetti-like streams, with some astronomers speculating about hidden magnetic or gravitational interactions. The dust itself is equally puzzling, shifting in color from red to blue to white, indicating multiple particle types and compositions being ejected at different times. This rainbow-like display suggests a level of complexity that points to a comet unlike any other. Webb's thermal data has also raised new questions about the comet's structure. The sunlit side of 3I/ATLAS glows with the heat of sublimating carbon dioxide, while the night side remains oddly cold, indicating that heat does not penetrate deeply into its nucleus. This contradicts what scientists see in normal comets, which usually distribute heat more evenly through their interiors. On top of that, Webb captured jets of hot gas erupting from isolated regions of the surface, further evidence that the comet is a patchwork of materials with radically different properties. Perhaps the most unsettling revelation is that 3I/ATLAS's chemistry is changing as it draws closer to the Sun. New molecular species are appearing in Webb's spectra, as though layers of exotic compounds are being unlocked from deep within the comet's core. Taken together, these findings suggest that 3I/ATLAS is not simply another icy wanderer, but a messenger from a completely alien planetary system, carrying within it materials and processes that may be unlike anything ever encountered in the history of astronomy. The final window. Here's what's making this discovery so urgent and terrifying. During September 2025, 3I/ATLAS will remain in the constellation Libra as it brightens from apparent magnitude 14 to 11.7. As the comet approaches perihelion in October 2025, the comet's solar elongation will decrease. Translation: we're in the final countdown to lose this cosmic visitor forever. Every day that passes, 3I/ATLAS gets brighter and more active, but it also gets closer to its final farewell. The recent images show a comet that's literally transforming before our eyes as it approaches the Sun. The dust production is increasing exponentially, the chemical composition is evolving, and the structure of the coma is becoming more chaotic by the hour. What's particularly spine-chilling is that astronomers are starting to detect signs that 3I/ATLAS might be breaking apart. The latest Hubble images show what appear to be separate condensations within the coma, bright spots that could be fragments of the original nucleus that have split off and are now evaporating independently. If 3I/ATLAS is indeed fragmenting, we might be witnessing the complete destruction of an object that traveled millions of light years to reach us. Think about that for a moment. This cosmic messenger survived the journey between star systems, endured the cold emptiness of interstellar space for potentially billions of years, only to disintegrate just as it's giving us our best chance to study its alien chemistry. The fragmentation possibility is both heartbreaking and scientifically incredible. If the comet does break apart, it will expose fresh material from its interior that's been preserved since its formation in an alien star system. We could get to see the pristine chemical composition of the object's core material that's never been touched by our sun's radiation. The carbon dioxide dominance. 3I/ATLAS has stunned astronomers by defying the basic rules of comet chemistry. Instead of being dominated by frozen water, like every comet we know from our solar system, this interstellar visitor is composed mostly of carbon dioxide, possibly more than 80% of its volatile materials. That makes it less like a typical comet and more like a frozen ball of CO2, something scientists thought couldn't naturally form under known cosmic conditions. Its very existence suggests that 3I/ATLAS was born in an environment radically different from anything near our Sun, perhaps around a carbon-rich star, or even during an earlier era of the universe. What makes this discovery even more extraordinary is how the comet is evolving as it heats up near the Sun. Observations reveal that its layers are packed with exotic ices, which begin to sublimate at different temperatures, releasing molecules never seen before in our solar system. From rare isotopes to complex organic sulfur compounds, 3I/ATLAS behaves like a layered onion of alien chemistry, with each level unveiling new surprises. This constant chemical transformation has made it one of the most challenging and exciting objects for researchers to track, as its molecular signatures shift almost daily. The detection of complex organic molecules in particular has raised profound questions. While there's no claim of life, the intricate chemistry suggests that the environment where 3I/ATLAS formed was capable of producing highly sophisticated compounds under conditions we don't yet understand. Some of these molecules require formation environments unlike anything in our solar system, pointing to the idea that alien planetary systems might operate under entirely different chemical rules. In short, 3I/ATLAS is a messenger carrying secrets from a cosmic laboratory we've never seen before. The structure, revelation. Astronomers combining Hubble's optical images with Webb's infrared data have revealed that 3I/ATLAS is far stranger than the typical comet. Instead of a simple icy rock, it appears to be a layered and structured object with regions that behave very differently. Optical images show contrasting bright and dark patches, possibly exposed ice in some areas, and nearly invisible dark surfaces in others. Meanwhile, Webb's infrared readings suggest an insulating outer layer that shields deeper ices, explaining why this interstellar object became active much farther from the Sun than expected. Even more intriguing, recent observations hint that 3I/ATLAS might not be a single body at all, but rather a contact binary, two objects barely bound together by gravity. If confirmed, it would be the first known interstellar binary comet. This cosmic pairing raises big questions. How did two separate fragments from another star system remain locked together across interstellar space? And will the Sun's heat eventually tear them apart? The mystery deepens as astronomers note that the true nucleus remains hidden, shrouded by constant outgassing that makes direct observation nearly impossible. Because the nucleus is obscured, scientists are forced to study it indirectly through the dust and gas it ejects. This is highly unusual, since even active comets normally allow glimpses of their cores during quieter phases. For 3I/ATLAS, the nucleus stays cloaked, leaving only fragments of its story to be pieced together from its emissions. Some researchers hope that closer to the Sun, solar heating might clear enough material to expose its hidden core. Others worry the opposite, that rising activity will intensify the veil, keeping its most important secrets forever out of reach. The activity, explosion and fragmentation, possibility. 3I/TLAS is rapidly transforming as it approaches its October 2025 perihelion, and astronomers are stunned by its behavior. In just weeks, its brightness has jumped nearly tenfold, from magnitude 14 to 11.7, far faster than any model predicted. What began as a quiet comet with modest outgassing has now turned into a raging celestial spectacle, ejecting vast amounts of material into space and forming a coma so large that even amateur astronomers with modest telescopes can see it. Unlike most comets that brighten gradually in predictable ways, 3I/ATLAS is defying expectations and following its own explosive path. What makes this surge even more dramatic is the feedback loop driving it. As more material blasts off its surface, the expanding coma absorbs more solar radiation, which in turn accelerates further outgassing. This runaway process raises fears that the comet may be heading toward a catastrophic breakup, completely disintegrating in a spectacular explosion of dust and gas. Hubble's latest images add weight to this concern, revealing multiple bright condensations in the dust coma that could be freshly separated fragments of the nucleus. If confirmed, it means 3I/ATLAS is actively breaking apart right now. Such an event would mark the first real-time observation of an interstellar object fragmenting before our eyes. The potential scientific payoff is enormous. Fragments could expose pristine material from deep inside, offering a once-in-history glimpse into the primordial chemistry of another star system. Yet, fragmentation also complicates the mission. Pieces may scatter unpredictably, making close study more difficult, whether we're witnessing the comet's death throes or its return to its original, loosely bound state. Each observation carries a sense of urgency and awe. Humanity may be watching the final moments of a cosmic traveler that has journeyed across the stars for millions of years, only to meet its end in our solar system. The detection revolution. The study of 3I/ATLAS marks a milestone in humanity's ability to investigate interstellar visitors. Unlike the fleeting glimpses we had of Oumuamua in 2017 and the limited details from 2I/Borisov in 2019, 3I/Atlas is being observed with unprecedented precision. Astronomers can now track dust jets, follow changes in the coma's structure, and even measure surface temperature variations. This leap in observational power is made possible by coordinated efforts across observatories. Hubble delivering high-resolution imagery, Webb providing chemical fingerprints, and ground-based telescopes monitoring brightness and motion. Together, they are building the most complete profile of an interstellar object in history. The global urgency to capture data before 3I/ATLAS disappears behind the Sun has fueled extraordinary cooperation. Professional observatories are synchronizing their schedules for continuous monitoring, while amateur astronomers are contributing critical observations to fill data gaps. The comet's rapid evolution, its brightness, jets, and overall activity changing within days, make every observation a potential breakthrough. This collaboration is setting a new standard for how the astronomical community responds to rare, fleeting cosmic events, with near real-time data sharing creating a unified global investigation. Beyond the immediate excitement, 3I/ATLAS is reshaping our understanding of planetary formation and interstellar chemistry. Its strange composition and volatile behavior are already prompting revisions to established theories, while the data collected is helping refine models of how planets and small bodies form around other stars. The discovery is also driving interest in future missions designed to intercept and study interstellar objects directly. Perhaps the greatest legacy of 3I/ATLAS is the realization that these visitors are vital messengers carrying chemical clues from alien star systems. The images and data from this comet will serve as a foundation for decades of research, marking humanity's first detailed look at material from another world. The final images of 3I/ATLAS reveal an interstellar visitor unlike anything seen before, defying assumptions about how objects from other star systems should behave. With its unusual size, exotic carbon dioxide chemistry, and hints of fragmentation, it is rewriting the rules of interstellar astronomy. As it makes its last close pass by the Sun before vanishing forever, 3I/ATLAS offers humanity the most detailed glimpse yet into the mysteries of alien worlds, an extraordinary moment in astronomical history. Which 3I/ATLAS discovery shocks you most? Its strange chemistry, structure, or possible breakup? Share your thoughts in the comments and subscribe for more cosmic mysteries.